All right, in part 2 of our video for section 9.2, this is very similar to what we did in section 1. So again, if you have not done so, please download the file on my website on chapter 9 called Special Right Triangles Exploration. And so in video 1, I asked you guys to take these 4 problems and solve for the missing side using Pythagorean theorem. And we came up with a pattern. When the angles were 30, 60, and 90, we came up with a ratio of 1 to root 3 to 2. And again, we'll explore examples of that in video 3. But for video 2, what I'd like for you to do is similar to what we did in video 1. I'm going to give you 4 problems here, numbers 1 through 4. And each one of these is in a 45, 45, 90 triangle. Now, number 4, it doesn't specifically say that it's 45 and 45, but it does give you tick marks. And these tick marks tell us that it is an isosceles triangle. And in an isosceles triangle, if two sides are congruent, or excuse me, if two sides are congruent, then the angles opposite them are congruent. And so since we already have a 90-degree angle here, the two remaining angles must be 45. And so that is actually how they'll disguise problems, especially on ACT and SAT. They will not necessarily give you the 45 and the 45, but they'll give you tick marks that allow you to deduce that. And so I'll go ahead and pause to give you guys an opportunity to stop the video and try to solve these 4 problems using the Pythagorean theorem. Okay, so hopefully you attempted each of the 4. Number 2 was a little tricky, so if you ran into issues there, that's fine. Number 3 was also a little difficult if you're having trouble with radicals, so we can discuss each one of those. And so on number 1, we set up the Pythagorean theorem, 3 squared plus 3 squared equals c squared, and we solve, we end up with 3 times the square root of 2. On number 2, and this one was a little harder, we did x squared plus x squared equals 16 root 2 squared. And so this had 2 parts that were kind of tricky. The first being what to do when you have x squared plus x squared. And so if I look at these, you can't expand those. There's really nothing to do with them. And so what I was really wanting you to do was recognize that they were like terms. And so you could add them together the same way you would say that x plus x is equal to 2x, x squared plus x squared is equal to 2x squared. And so that's where this guy came from. And then the second part that was a little tricky was the right side over here, which was you had to do 16 root 2 squared. And we'll go ahead and slide that over here. And so if you have not watched video 1, in video 1 I showed you how to handle these. So anytime you do something squared, you're multiplying that number times itself. And so 16 root 2 times 16 root 2, you do 16 times 16, which is 256. Root 2 times root 2, which is root 4, and the square root of 4 is 2. And then 256 times 2 is 512. And so that's where this 512 came from. And then on each side, you'll want to divide by 2, which leads us to this. And then x squared is equal to 256. You take the square root of both sides, and the square root of 256 is 16. Just a minor note is the answer to this is actually plus or minus. And so the answer is plus or minus 16. But since we're talking about side lengths in a triangle, we're not really worried about the negative 16. And so we just strictly look at the positive 16. So knowing all that, if we look at the pattern here, one thing you'll notice is these are isosceles triangles. So the 2 legs will always be equal to each other. And then it looks like the hypotenuse is pretty much just this number multiplied by root 2. Same thing over here, we got 16 and 16, and the hypotenuse is 16 root 2. And so this is actually an easier pattern to deal with. And so now if we look at numbers 3 and 4, again, if you have not done these, go ahead and pause the video and try to solve using the Pythagorean theorem. And the whole point here is I want you to see the pattern using Pythagorean theorem, but then recognize there are other ways to do these, and there's actually going to be some problems where the Pythagorean theorem is not going to be an option. So in number 3, again, a little more difficult, you have to do 4 root 3 squared plus 4 root 3 squared equals c squared. If we go through that whole process, you end up getting the square root of 96, which simplifies to 4 root 6. And the pattern we figured out on number 1 and number 2, where you just take the leg and you multiply by root 2, seems to hold here. Because if you take 4 root 3, which is the length of each of the legs, multiply by root 2, you end up getting 4 root 6. Again, you do outside times outside, inside times inside. And then number 4 was actually a little bit easier than 2 and 3. You do 11 squared plus 11 squared is equal to c squared. The annoying part about this is when you solve, you get the square root of 256, and that actually simplifies to 11 root 2. So again, it's the leg times root 2. And that is actually our second special triangle. And these are called 45, 45, 90 triangles. And so these, similar to what we said before with 30, 60, 90, you've got the 45, which is the leg. And again, we're trying to pair these up. So you match the 45-degree angle up with the side that's across from it. And then this 45 matches up with this. And these are both the same. And then the right angle matches up with the hypotenuse. So this says in a 45, 45, 90 triangle, the ratio of the three sides is 1 to 1 to root 2. So that says that these two sides are the same, and then the length of the hypotenuse is always whatever these are multiplied by root 2. So in video 3, we will use this relationship, the 45, 45, 90, and the 30, 60, 90, and we'll walk through some examples to see how we use those.